Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. Today we are going to solve a problem on axial load. So you can read the problem over here. So the non-prismatic cantilever circular bar. First, what is a non-prismatic bar? Actually, there are two types of bars. One is prismatic bar, another is non-prismatic bar. Okay. So what is a prismatic bar? In prismatic bar, the cross-sectional area will be constant throughout the length. Okay, means if it has constant cross-sectional area. For example, this is a prismatic bar with area A. Okay. This is also a prismatic bar with area A equals to L into B. Okay. So these bars have constant cross-sectional area. So then what is non-prismatic bar? It don't have a constant cross-sectional area. For suppose it will have varying cross-sectional area, maybe uniformly varied, abruptly varied. For example, these two are prismatic. This is non-prismatic, right? So this one, similarly, a rectangle varying cross-sectional area, rectangle varying cross-sectional area can also be possible. So this is non-prismatic. So if you see here, this has cylindrical hole. This is hole. So this has a different cross-sectional area. Here it is A. Here it is 3 by 4 into A. So this is also a non-prismatic bar. So let us read ahead. Load P is applied at X. So here load P is applied. You see here load P is applied and load P by 2 is applied at L, at a distance L. So assume that E is constant. So what does it signify? Means we need to assume that the body is made up of homogeneous and isotropic material. So only this type of material will have single value of elastic property throughout the body. So now let us move to the question. Part A, find reaction force R1. So for reaction force, as this is fixed to the support, whatever load you may apply, it will be in equilibrium, right? So you can use equilibrium equation. So sigma fx is equals to 0. This is part A. So what is, suppose if you say this is positive x direction, then R1 plus P by 2 is equals to 0, right? So R1 is equals to minus 3P by 2, right? So R1 is equals to minus 3P by 2. 3P by 2 is the answer for part A. Now let us move to part B. So in part B, we need to find out internal forces in segment 1 and segment 2. So let us draw the diagram. This is a fixed support. We have two segments. This is pole. So this is segment 1, this is point 1, this is point 2, this is point 3. So this is segment 2, this is segment 1. This is of distance x. This is L minus x, right? So this has area 3 by 4 A. This has area A. Here P by 2 is applied. Here P is applied. Okay. So we need to find out internal forces in section 1 and section 2, segment 1 and segment 2. So there is reactive force in this direction that is given by 3P by 2 R dash. Okay. This is reactive force. Okay. So see, if a member is in equilibrium, then every part of the member will be in equilibrium. So to find out internal forces in segment 1, we need to hurt the element in segment 1. So then you can take this part. Here there is force 3p by 2. Then we already know that tensile is positive, so away from the cross section is positive. That is N1, internal force, internal normal force in segment 1. So this is some distance. Then if you can apply sigma fx is equals to 0, it will give you N1 minus 3p by 2 is equals to 0. That is N1 is equals to 3p by 2. Okay. You can also apply equilibrium equation to the right part of it. Let us see. So here equivalent opposite N1. So see, you can, this is whole. You can apply here also sigma fx is equals to 0. That will give you minus N1 plus p by 2 is equals to 0. Again N1 is equals to 3p by 2. This is part 1. We need to find for segment 2 also. For segment 2, you should cut it in segment 2. So you can take right part. So again tensile is positive, so take N2 away from the cross section as positive. Again sigma fx is equals to 0. Then it gives minus N2 plus p by 2 is equals to 0. N2 is equals to p by 2, right? So internal normal force in segment 1 is 3p by 2 and in segment 2 is p by 2. So we completed part A. Part A answer is minus 3p by 2 and we completed part B. N1 is 3p by 2 and N2 is p by 2. Now let us go to part C. Find x required to obtain axial displacement at joint 3. Joint 3 del 3 is equals to PL by EA. Means we need to have 3 ka displacement delta 3, that should be is equals to PL by EA, right? So what is del 3? That we need to understand first. So if you take C, so this is the rod. If you take this is a rod. Okay. So this is rod and this is X. This is L minus X. Here P by 2 is applied. Here P is applied. And this is 0.3. Let us take this is 0.2. This is 0.1. This is A, B, C. Okay. So what is the del A? What is the value of del 1? So it means C, it is fixed at the support. So whatever elongation it may have, but the material which is present near the support, which is at the support, has zero elongation, right? So we can say del 1 is equals to 0. So if you take one example, this is the rod and you applied some loads P by 2 and we know that 1 ka elongation 0. So after elongation also 1 will stay here. This is 3. Finally suppose elongation is up to here, so this is 3 dash, right? So if you take this one, so this is the moment of 3, right? So this is del 3. That means del 3 will be is equals to del 3 1. That means elongation of whole bar, right? So we need to find out elongation of the whole bar. So for that we already have N1 is equals to 3p by 2, right? N2 is equals to p by 2. And we already know that if there is a bar and it has equivalent opposite load P, then what is elongation? Elongation will be is equals to PL by EA, right? We already have this thing. So here there are these type of links. Here there are two bars similar to like this, right? So then delta 3 1, which is equals to delta 3, will be is equals to delta 2 1 plus delta 3 2. Delta 2 1 is the elongation of segment 1. This is segment 1. Delta 3 2 is elongation of segment 2. So what is delta 2 1? Delta 2 1 is 3p by 2 into distance is x divided by e into area is 3 by 4a plus what is elongation of segment 2? It is p by 2 into this is 3p by 2, yes, this is p by 2 into what is the distance? L minus x, length of the bar, divided by e into area is a. So this should be is equals to PL by EA, that is given, right? So you can write it as 3 cancels and 2 cancels 2 times. So you can write it as 2px by EA plus p of L minus x divided by 2EA is equals to PL by EA, right? So you can cancel P by EA, right? So it will give 2x plus L minus x by 2 is equals to L, right? So it will give 2x minus x by 2, 3x by 2 plus L by 2 is equals to L. So 3x by 2 x by 2, 3x by 2 is equals to L minus L by 2, that is L by 2. So x is equals to L by 3. So to have the whole elongation of the bar equals to PL by EA, we need to have the value of x to be L by 3. So that P load which is applied at P, that should be at L by 3 starting from the fixed support. Okay. So we completed part C also. Answer is x is equals to L by 3. Here N1 is equals to 3P by 2, N2 is equals to P by 2. So here R1 is equals to minus 3P by 2. With this we end today's lecture. In next lecture we are going to solve this question only, but have this question has 3 more parts. We will solve that in next lecture. Until then, take care. Bye bye from 9pointer.